You configure a router interface, assign an IP address, and hit No Shutdown. The interface stays down. Every packet you send vanishes into the void. The network is dark. What went wrong? It starts with understanding how IPv4 addresses work. In Chapter 6, we learned how switches forward frames using MAC addresses at Layer 2. Now we move up to Layer 3, where routers use IP addresses to make forwarding decisions. This is the foundation of every network on the planet. The IPv4 header carries everything a router needs to deliver a packet from source to destination. It is 20 to 60 bytes long, with 14 fields. The version field tells you whether this is IPv4 or IPv6. The IHL field says how long the header is, because the options field makes it variable. DSCP and ECN prioritize traffic for quality of service. Total length covers the entire packet. Identification, flags, and fragment offset handle fragmentation when packets exceed the MTU, usually 1,500 bytes. The TTL field is critical. Without it, a misconfigured router can loop packets forever. Each router decrements TTL by 1. When it hits 0, the packet dies. That is your network safety net. The protocol field tells the destination what is inside the packet. 1 for ICMP, 6 for TCP, 17 for UDP. Header checksum verifies the header integrity. And then the two fields that matter most, source address and destination address, each 32 bits. But before you can read those addresses, you need to understand binary. Computers only speak zeros and ones, and every CCNA question about IP addressing requires you to convert between decimal and binary. Decimal uses 10 digits, 0 through 9. Binary uses 2 digits, 0 and 1. In binary, each position doubles in value. The rightmost bit is worth 1, then 2, 4, 8, 16, 32, 64, and 128. To convert binary to decimal, add the values of every bit set to 1. To convert decimal to binary, subtract the largest possible bit value and write a 1. Then keep going with the remainder. Practice this until you can do it in your head. Cisco has a free binary game on their learning network. Use it. An IPv4 address is 32 bits, split into 4 octets of 8 bits each. We write it in dotted decimal notation. Each octet is a number from 0 to 255. The address is divided into 2 parts, the network portion and the host portion. The prefix length, written as /x, tells you how many bits belong to the network. A /24 means the first 3 octets are the network, and the last octet identifies individual hosts. All hosts in the same LAN share the network portion. Each has a unique host portion. You can also express the prefix length as a net mask. A /24 becomes 255.255.255.0. The ones in the net mask mark the network bits. The zeros mark the host bits. Now back to that broken router. You enter interface configuration mode, assign the IP address with the IP address command, and use the net mask, not the prefix length. Cisco iOS requires net masks. Then you issue no shutdown. The interface comes up. But what addresses can you actually assign? The network address, where all host bits are 0, identifies the network itself and cannot be assigned to a host. The broadcast address, where all host bits are 1, sends a message to every host on the network. The first usable address is 1 above the network address. The last usable address is 1 below the broadcast address. For a /24 network, that gives you 254 usable hosts. 2 to the power of 8, minus 2. The minus 2 accounts for the network and broadcast addresses. Originally, IPv4 addresses were organized into 5 classes. Class A uses a /8, giving 128 networks with 16 million hosts each. Class B uses /16, 16,000 networks with 65,000 hosts each. Class C uses /24, over 2 million networks with 256 addresses each. Classes D and E are reserved for multicast and experimental use. This classful system is obsolete. Modern networks use classless addressing, where prefix lengths are not restricted to /8, 16, or 24. We will cover that in Chapter 11 when we tackle subnetting. Some addresses are reserved and cannot be assigned to hosts. 0.0.0/8 is reserved. 127.0.0.0/8 is the loopback range. Ping 127.0.0.1, and the packet never leaves your device. It is how you test your own network stack. On the exam, you will be asked to identify network addresses, broadcast addresses, and usable address ranges. You will need to convert between binary and decimal quickly. The exam is timed at 2 hours, so speed matters. The key takeaway: every IP address has a network portion and a host portion. Prefix length, or net mask, tells you where that division happens. Everything else flows from that rule. Configure the right address, enable the interface, and the network lights up.